Mathematical modeling. Mathematical modeling is a process of converting real world problems into equivalent mathematical problems. Now consider one problem where a person is walking and I should find the distance traveled by the person. Okay, find the distance traveled by a walking person in 60 minutes and 30 minutes, and given that the person travels 10 meters in 1 minute. Okay, now I should find what is the distance traveled by the person in time is equal to 60 minutes. Okay, now we know that in 1 minute the person travels 10 meters. Okay, therefore in 60 minutes he will travel, it's just cross multiplication. Okay, so 60 into 10 by 1, this gives 600. So this cross multiplication method is unitary method. Okay, so I'll get 600 meters as the answers. So in 60 minutes he will travel 600 meters, and for time is equal to 30 minutes. Okay, so again here also we know that in 1 minute he will travel 10 meters. Therefore in 30 minutes he will travel, again here also it's unitary method, just cross multiply 30 into 10 by 1, which gives 300 meters. So here the given problem is a real world problem. Okay, find the distance traveled by a walking person in 60 minutes and 30 minutes. This is a real world problem, and you can see how mathematically I have modeled this problem and I found a solution. Okay, not only for time is equal to 60 minutes or 30 minutes, for any given time I can calculate the distance traveled by this person. Same problem I'll solve using another method. Here I'll use the formula speed is equal to distance traveled by time taken. Okay, now given that the person travels 10 meters in 1 minute, it's given in the question itself, so his speed will be 10 meters divided by 1 minute, so this gives 10 meters per minute. Minute is the speed of the person. Okay, and also speed is equal to distance traveled by time. Therefore when I cross multiply I'll get speed into time is equal to distance traveled. So in first case, for time is equal to 60 minutes, I should find distance. Okay, so speed is equal to, distance is equal to speed into time taken. Therefore yes, we know that it is 10 meters per minute. So 10 into time is 60 minutes, so 10 into 60 is 600 meters. Similarly, for time is equal to 30 minutes, I should find the distance traveled by the person. So d is given by s into t. So s is 10, t is 30 now, so this is 300 meters. So here also what I have done is I have found the formula for distance traveled, and using that formula I am finding the distance traveled by the person for any given time. So here the given problem was a person is traveling and we should find the distance traveled by the person for any given time. So I have come up with two models here. In the first model I have found the distance traveled using unitary method, and in the second method I have found the distance traveled by using the formula distance is equal to speed into time taken. So this is how we do mathematical modeling for any given real world problem. There could be more than one mathematical model for any given real world problem. Okay, now consider another example where we need to find the number of fishes in a pond. Okay, this example is given in the textbook also. Okay, now if the pond is very big and if there are large number of fishes, then it is practically not feasible to catch all the fishes and count. Instead we can sample a small number of fish also, and we can calculate. Let us see how this can be done. Okay, now let the number of fishes be x. Okay, now what I will do is I'll catch only 20 fishes and mark them. Okay, I'll do some marking on them. Therefore, the number of marked fish by total number of fishes will be equal to now 20 by x. Okay, now this I'll mark as 1. Now what I'll do is I'll release all the fishes back to water or back to pond, so that they mix up in that pond. Okay, after this what I'll do is again I'll catch 50 fishes. Now here the number of fishes which I am going to catch will be more than the number of fishes which I caught before. Okay, catch 50 fishes and check how many fishes are marked. Okay, in the first attempt when I caught 20 fishes, I marked all the 20 fishes. Now here I'll catch 50 fishes, and out of those 50 fishes, how many are marked fishes I'll see. Okay, let the number of marked fishes be 5. Okay, out of this 50 fishes, let 5 fishes be the number of marked fishes. Therefore, now number of marked fishes by number of caught fishes will be equal to, this time I caught 50 fishes. Okay, and out of that 5 fishes are marked. Okay, so now the ratio is 5 by 50. Now this I'll mark as 2. Now actually 1 should be equal to 2. Okay, so I'll equate, so 20 by x is equal to 5 by 50. Now if I cross multiply, I'll get 20 into 50 is equal to 5 into x, or x is equal to 20 into 50 by 5 I will get. Now 5 1s are 5, 5 10s are 10. 10 into 20 is 200. So 200. So actually in this pond there will be 200 fishes. So this method can be applied for any pond, and we can find the number of fishes. It's not necessary to catch all the fishes. Only a fraction of fish we can catch. We can mark them, and this is how we find the total number of fishes in the pond. So this is a mathematical model now which we have found out to find the number of fishes in the pond. Stages in mathematical modeling. The first stage is understanding the problem. Okay, define the real problem. If working in a team, discuss the issues that you wish to understand, simplify making assumption and ignoring certain factors so that the problem is manageable. So first we should understand the problem and make some assumption. So in this fish problem, you can see in this pond there may be many small fishes which we can't catch. So one assumption here is all fishes are of some size, so that it can be caught. So there are no small fish. That's one assumption in this problem. Okay, and the second step is mathematical description and formulation. Describe in mathematical terms the different aspects of the problem. Some ways to describe the features mathematically include define variables, write equation or inequalities, gather data and organize into tables, make graphs, calculate probabilities. So in this fish problem only, so we found one ratio, that is number of marked fish by total number of fishes. We got 20 by x, and also in the second case we got number of marked fishes by number of caught fishes to be equal to 5 by 50. Okay, like this we can make some equations, and after that solving the mathematical problem. So again, coming to this fish problem, we got two equations and we equated those two equations, and we finally found the value of x. X is the number of fishes in this pond, and interpret the solution. The solution obtained in the previous step is now looked at in the context of real life situation that we have started within step 1. So after getting the solution, we should interpret the given solution with the real life situation. Okay, and the next step is validating the model. We go back to the original solution and see if the result of the mathematical work makes sense. If so, we use the model until new information becomes available or assumption change. So whatever result we have got, it should make some sense. Okay, and if it's not making some sense, means that means our assumption could be wrong. Okay, sometimes because of the simplification assumptions we make, we may lose essential aspects of real life problems while giving its mathematical description. In such case, the solution could often be off the mark and not make sense in the real situation. If this happens, we reconsider the assumption made in step 1 and revise them to be more realistic, possibly by including some factors which are not considered earlier. So if the result is not making sense, then maybe the assumptions which we made in step 1 is not proper, and we are going to make new assumptions and solve it. So here you can see the workflow of the mathematical model. So for any real life problem, first we'll make some assumption and we'll simplify it, describe the problem in mathematical terms. Okay, then solve the problem, interpret the solution in real life situation, and here in the last we should validate, does the solution capture the real life situation. If it is not so, then our assumption might be wrong. Therefore we go back and make some changes in the assumption, and again we'll check. So finally, when the solution matches with the real life situation, then that model is suitable. Next in this chapter is a exercise problem, exercise A 2.1. Consider the following situation: a problem dating back to early 13th century posed by Leonardo Fibonacci asks how many rabbits you would have if you started with just 2 and let them reproduce. Assume that a pair of rabbits produce a pair of offsprings each month, and that each pair of rabbit produce their first offspring at the age of 2 months. Okay, month by month the number of pair of rabbits is given by the sum of the rabbits into preceding months except the 0th and the 1st month. So here there is one pair of rabbit, and that pair of rabbit, it will reproduce in 2 months. Okay, so initially one pair of rabbit is there, so in the next month that rabbit will not reproduce. Okay, it will be like as it is. Okay, and in the second month that pair of rabbit will reproduce. Therefore in the second month the number of total number of pairs of rabbits are 2. So like this, if it goes on, it goes on. Okay, every new pair of rabbit which is born, it will start giving birth to another pair of rabbit after 2 months. So like this going on, what is the number of rabbits after 16 months? Okay, after just 16 months you have nearly 1600 pairs of rabbits. Okay, clearly state the problem and different stages of mathematical modeling in this situation. Okay, suppose if this actually the answer is given here. Okay, after each and every month what is the number of pairs of rabbit it is given here. Suppose if this last column, if the pairs of rabbit, if it is not given, and if we were asked to find the number of rabbits after some months, how do we proceed? That's the question. Let us see how to solve this problem. I have made a new table. It consists of 3 columns. First column consists of months. The second and third column consists of number of pairs of rabbits. Okay, and the month they have counted from 0. Okay, 0, 1, 2, 3, 4, 5, so on. Instead of that, we can put 1, 2, 3, 4 also. We can count from 1 also. That's not an issue. Okay, so at 0th month there will be only 1 pair of rabbit. Okay, and every pair of rabbit, it gives birth to a new pair after 2 months. So this pair of rabbit will be there as it is in the first month, but in the second month it will give birth to new pair of rabbit. Therefore in the second month there will be 2 pair of rabbit. Okay, so I am writing here there are 2 pairs of rabbit in the second month. In the first month it is 1 pair, and in the 0th month also it is 1 pair. Now coming to the third month, these 2 pairs of rabbits will be there as it is, but the first pair of rabbit, now it is more than 2 months old, so it will be giving birth to another pair of rabbit here. So in third month there are totally 3 pairs of rabbit. Now again coming to the 4th month, these 3 pairs of rabbit will be there as it is, but these 2 pairs of rabbit, they are now 2 months old or more than 2 months old. Therefore they will give birth to another 2 pairs of rabbit. So totally there are 5 pairs of rabbit in the 4th month. And coming to the 5th month, these 5 pairs of rabbit will not die, they will be there as it is, and these 3 pairs of rabbit, they are 2 months old or more than 2 months old. Therefore they will give birth to another 3 pairs of rabbit. So totally there are 8 pairs of rabbit here, and all these 8 pairs of rabbit, they won't die, so they will be there as it is in the 6th month also. Okay, and all the rabbits in the 4th month, they are 2 months old or more than 2 months old. Therefore they will give birth to another 5 pairs of rabbits here. 1, 2, 3, 4, 5. So totally there are 13 pairs of rabbits here. Now all these 13 pairs of rabbits, they will be alive in the 7th month also. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now all the pairs of rabbits in the 5th month, they are 2 months old or more than 2 months old. So they will give birth to another 8 pairs of rabbits. 1, 2, 3, 4, 5, 6, 7, 8. So totally there are 21 pairs of rabbit in the 7th month. And again going in the same way, in the 8th month there will be 34 pairs of rabbit. Now you consider only the last column. The first entry is 1. Okay, the second entry is 1. So if we add the first 2 entries, 1 plus 1, we get 2. That is the third entry. Now second entry is 1, third entry is 2, 1 plus 2 is 3. Okay, we get next entry. Okay, now again if we add 2 plus 3, we get 5. 2 plus 3 is 5, the next entry. Again if we add 3 plus 5, if we add, we get 8. That is the next entry. Again 5 plus 8 is 13, the next entry. 13 plus 8 plus 13, we get 21. And again 13 plus 21, we get 34. Therefore the number of pairs of rabbit in any month is given by the sum of the number of pairs of rabbits in the last 2 months. Here you can see this sentence. In the question only they have told that month by month the number of pairs of rabbit is given by the sum of the rabbits in the 2 preceding months except for the 0th and the 1st month. Okay, if we take R to be the number of pairs of rabbits in any month and N to be the month, then number of rabbits in any month is given by R of N, which is equal to R of n minus 1 plus r of n minus 2. That is, the number of rabbits in any month is given by the sum of the number of rabbits in the preceding 2 months. The list of number in the last column, that is 1 1 2 3 5 8 13 21 34 and so on, this is called as Fibonacci series of numbers. Okay, this is a very important and very vast subject, and you may study this Fibonacci series in detail in your higher studies. Next in the textbook is an example. So example of rolling a pair of dice. Suppose your teacher challenges you to the following guessing game. She would throw a pair of dice. Before that, you need to guess the sum of the numbers that show up on the dice. For every correct answer, you will get 2 points, and for every wrong guess, you will lose 2 points. What numbers would be the guess? So in any dice, there will be numbers from 1 to 6. So when we throw a pair of dice, these are the possible outcomes. Okay, it may show up 1 1, or it may show up 1 2 1 3 1 4 1 5 1 6, or 2 1 2 2 2 3 2 4 2 5 2 6, and so on like this. Okay, so totally there are 36 outcomes, and we should guess the sum of the numbers that show up on the dice. For example, if outcome is 1 comma 1, then the sum will be 1 plus 1 is equal to 2. Suppose if the outcome is 6 comma 6, then the sum of the number is 6 plus 6, that is 12. Okay, before throwing the dice, we should guess the sum of the numbers that show up on the dice. Okay, and whenever our guess is correct, we get 2 points, and whenever our guess is wrong, we lose 2 points. So here you can see the minimum number we get is 1 plus 1 2, and the maximum number is 12. So the sum of the number that shows up on the dice is 2 3 4 5 6 7 8 9 10 11 and 12. Maximum will be 12. So which number do we guess? Okay, what numbers would be the guess? Now let us see how to solve this problem. Here I have written the same outcomes. Here on the right side, you can see there are totally 36 outcomes. Okay, there are, you can see here, there are 6 rows. Okay, there are 6 rows, and there are 6 columns. Okay, therefore possible number or total number of outcomes is equal to 6 into 6, which is equal to 36. Okay, and the sum of the numbers that show up is 2 3 4 5 6 7 8 9 10 and 12. 2 3 4 5 6 7 8 9 10 11 and 12. For example, if we get outcome as 1 comma 1, then 1 plus 1 is 2, right? And that is 2 here. Okay, sum is 2. Suppose if we get 1 comma 2 or 2 comma 1, then 2 plus 1 is 3, and 1 plus 2 also is 3. So that 3 is here, you can see. And suppose if the outcome is 6 comma 6, then the sum will be 6 plus 6, which is equal to 12. So that one I have shown here. So 2 3 4 5 6 7 8 9 10 11 12 and 11 up till 12 are the possible number of sums that we get. Okay, now out of these 36 outcomes, how many outcomes do we get 2? Only one. Here you can see 1 comma 1. So only in one outcome we get sum equal to 2. Therefore the probability of getting 2 will be equal to 1 by 36, where 36 is the total number of outcomes. Similarly, when the outcome is 1 comma 2 or 2 comma 1, the sum will be equal to 3. Okay, so therefore total number of outcomes here is 2. Therefore the probability of getting sum 3 is 2 by 36. Okay, similarly here you can see there are 3 outcomes where we get sum equal to 4. 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4. So number of outcomes here is 3. So out of 36, 3 is the outcome. Therefore probability of getting 4 is 3 by 36. Similarly, there are 4 outcomes where the sum is equal to 5. 4 plus 1 is 5, 3 plus 2 is 5, and 2 plus 3 is 5, 1 plus 4 is 5. Therefore probability of getting 5 is 4 by 36. Similarly, there are 5 outcomes where the sum is equal to 6. So probability of getting sum equal to 6 is 5 by 36. Similarly, probability of getting sum equal to 7 will be 6 by 36. There are totally 6 outcomes where we get sum equal to 7. Therefore probability of getting sum 7 is equal to 6 by 36. And probability of getting 8 is 5 by 36. And probability of getting 9 is 4 by 36. Probability of getting 10 is 3 by 36. So probability of getting 11, so that is 2. 6 plus 5 is 11, 5 plus 6 is 11. So there are 2 outcomes. Therefore probability of getting sum equal to 11 is 2 by 36. And at last, probability of getting sum equal to 6 is 1 by 36. So here you can see probability of getting sum equal to 7 is the highest. Okay, so in this guessing game, when we guess 7 as the outcome, then the chances of winning is more. So repeatedly in this game we should guess number 7, only then we can win this game. We will get more points and we are going to win it. Okay, so I have written that sentence. Since the probability of getting the number 7 is the highest, we should repeatedly guess the number 7. Did we follow the standard procedure of mathematical modeling in this problem? The first step is understanding the problem, second step is mathematical description, the third step is solving the mathematical problem, and the fourth step is interpreting the solution, and the fifth is validating the model. So the first step is understanding the problem. So the problem was a pair of dice is thrown and we need to guess the sum of the numbers that show up on the dice. Okay, and here not all the sums have equal chances of showing up. Okay, you need to know a few numbers which have higher chance of showing up. Okay, the second step is mathematical description. So when a pair of dice is thrown, totally there are 36 possible outcomes, and those outcomes are shown here mathematically. So those are 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, so on up till 6, 6. The third step is solving the mathematical problem. So we were supposed to guess the sum of the numbers that shows up. Okay, and the possible sums are 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. And when we calculated their probabilities, we found that the sum 7 has the highest probability, that is 6 by 36. Okay, and sum 2 has least chance of showing up, so because its probability is 1 by 36. And similarly 12, sum 12 also has least chance of showing up because probability of 12 is 1 by 36. So since sum 7 has the highest probability, what can we interpret? So we can interpret, since the probability of getting the sum 7 is highest, you need to repeatedly guess the number 7. So if we repeatedly guess the number 7, then we are going to win this guessing problem. Okay, next is validating the model. Toss a pair of dice a large number of times and prepare a relative frequency table. Compare the relative frequencies with the corresponding probabilities. If these are not close, then possibly the dice are biased. Then we could obtain data to evaluate the number towards which the bias is. So what it means is, if we do this experiment many number of times, then probabilities of the sum should be close to these values. If the probabilities of the sums are not close to these values, then the dice may be biased. Okay. Next is another example in the textbook. Example 2. Juhi wants to buy a bicycle. She goes to the market and finds that the bicycle she likes is available for rupees 800. Juhi has rupees 600 with her. So she tells the shopkeeper that she would not be able to buy it. The shopkeeper, after a bit of calculation, makes the following offer. He tells Juhi that she could take the bicycle by making a payment of rupees 600 cash down, and the remaining money could be made into monthly installments of rupees 610. Juhi has two options. One is to go for installment scheme, or to make cash payment by taking loan from a bank, which is available at the rate of 10% per annum simple interest. Which option is economical to her? So here also we should follow the standard procedure of mathematical modeling. So the steps in mathematical modeling is: first step, understanding the problem; second step, mathematical description; third step, solving the problem and interpreting the solution; and the last is validating the model. Let us see how to solve this problem. In this problem, Juhi has to purchase a bicycle whose selling price is rupees 1800. Okay, she has two options. One is installment option and another is bank loan option. So in installment option, Juhi has to pay rupees 600 as cash down payment and pay two installments of rupees 610 rupees. Okay, or she can go and buy the bicycle by taking a loan. Okay, and the rate of interest in this loan is 10% per annum. So which is more economical is the question. So rate of interest of bank loan is already given, it's 10% per annum. So if I calculate the rate of interest of installment scheme, I can compare the rate of interest of installment scheme and bank loan scheme. Okay, and whichever interest rate is less, that option will be economical to Juhi. Okay. In the solution, first I'll calculate the percentage simple interest in installment scheme. Okay, so in installment scheme, the cash price of the bicycle is 1800, and cash down payment is 600. Therefore the balance will be 1800 minus 600 is 1200. Okay, now the total amount paid in this scheme is, that is 600 cash down payment plus 610 first installment. Okay, first installment, and again 610 this second installment. So this is equal to 1820. Okay, therefore interest paid will be, interest paid is equal to total amount paid minus cost price of bicycle. Okay, so total amount paid is 1820 minus cost price of the bicycle is 1800. So total interest paid is rupees 20. So Juhi pays 600 initially, that is cash down payment, and she pays 610 in the first installment and 610 in the last installment, that is second installment. Okay, so when she is paying 600 rupees as cash down payment, I'll call that as 0th month. Okay, 0th month. and when she is paying 610 rupees, I'll call that as first month, and when she is paying 610 rupees the second installment, I'll call that as second month. Okay, so in the first month she has already paid 600 rupees as cash down payment, so the balance here will be 1800 minus 600. 1800 is the cash price of the bicycle, so 1800 minus 600 is 1200. Okay, this first installment. And coming to second second month, balance. So balance will be, so in the first month 1200 was the balance. Okay, 1200 was the balance. She is paying 610 as the installment, so 590 will be the balance. Okay, 590 rupees. So 610 is the second installment. Now what is rate of what is simple interest? Simple interest is given by PTR by 100, right? So I'll call this as SI1, simple interest 1. So here principal will be the balance amount, so that is 1200 into time. Time will be 1 by 12 because time usually is taken in years. So here this interest is just for 1 month, that's why 1 year consists of 12 months, that's why time will be 1 by 12. Okay, this interest is for only 1 month, into R we don't know, divided by 100. So this is SI1. And coming to the second month, here this I'll call as SI2. So here again it is PTR by 100. So this is equal to, here principal will be the balance. So here in the second month the balance is 590 into, here also time will be 1 by 12 because this is just for 1 month. So 1 by 12 by rate of interest we don't know, by 100. So I'll call this as SI2. Now what is total interest? Okay, total interest is equal to interest paid in the first month plus interest paid in the second month, and we know that total interest is also equal to rupees 20. So this is rupees 20. So now add this, substitute the values of SI1 and SI2. SI1 is 1200 into 1 by 12 into R by 100 plus SI2 is 590 into 1 by 12 into R by 100 is equal to 20. So in the left hand side I can take 1 by 12 into R as common factor, 1 by 12 into R by 100 I can take common factor. So and the remaining I'll write here. So 1200 plus 590, like this I can write, this is equal to 20. Now if I cross multiply 1200 plus 590 into 1 by 12 into R is equal to 20 into 100. Now if I simplify R, so R is equal to 20 into 100. So the 12 in the left hand side, the 12 is in the denominator of the left hand side, that will come to the numerator. Okay, and 1250 plus 590, okay, this whole thing gives 1790. So this rate of interest I'll get as 13.4%. Okay, now what is the bank interest given? Okay, bank interest is just 10%. Okay, given bank rate of interest is equal to 10%. So bank rate of interest is less than the installment rate of interest. Installment rate of interest is 13.4%. So therefore Juhi should should prefer bank loan. Since the rate of interest of bank loan is 10%, which is less than the installment scheme, she will be paying less if she goes for bank loan. Let us see what is there in the textbook. In the textbook you can see they have calculated rate of interest to be 13.14. With these values actually we get rate of interest to be 13.4, okay, and the bank rate of interest is 10%. Therefore going for bank loan would be a better option for Juhi. You can read here, she should prefer to borrow the money from bank to buy the bicycle, which is more economical. Now validating the model. So in our calculation we have not considered the processing charges and stamp paper charges, okay. Whenever we go for bank loan there will be some processing fee and stamp paper charges and so on, okay. I can read here, this stage in this case is not of much importance here as the numbers are fixed. However, if the formality is for taking loan from the bank, such as cost of stamp paper etc., which make the effective interest rate more than what it is in the installment scheme, then she may change her opinion. So sometimes if we include all these charges like stamp paper charges and processing charges, then the total charges may be more than the installment scheme. That time we may consider taking installment scheme also. If you see the explanation given in the textbook and my explanation, they are bit different, okay. Whichever you feel is easy, you can go for it. It's always better to understand the problem first and prove the given problem by framing our own sentences, okay. Next in this chapter is exercise A 2.2. In each of the following problem, show the different stages of mathematical modeling for solving the problems. An ornithologist wants to estimate the number of parrots in a large field. She uses a net to catch some and catches 32 parrots, which she rings and sets free. The following week she manages to net 40 parrots, of which 8 are ringed. What fraction of her second catch is ringed? Find an estimate of total number of parrots in the field. So this ornithologist main aim is to find the number of parrots in the field, okay. So to do that, what she does is first she will catch 32 parrots and she will ring all those 32 parrots and she will set it free, okay. And again she will catches 40 parrots and she finds that out of those 40 parrots 8 parrots are ringed, okay. So coming to the solution, first one is what fraction of our second catch is ringed, okay. So here in second catch, number of caught parrots is equal to 40, and out of those 40, number of ringed parrots is equal to 8. Therefore ratio of ringed parrots to the total number of parrots caught is equal to 8 by 40, okay. So this I'll mark as A. Now this step is also the mathematical description, okay. In the stages of mathematical modeling, the second stage is mathematical description, okay. So here mathematically I have described the ratio of ringed parrots to the parrots caught, okay. And coming to the second sub question, so they are asking to find an estimate of the total number of parrots in the field. So here what I'll do is I'll assume x to be the total number of parrots, okay. Okay, in first case, she catches 32 parrots. Okay, therefore ratio of parrots caught to the total number of parrots is equal to 32 by x. Okay, 32 by x. Now this I'll mark as B. Now A should be equal to B. Okay, they'll be proportional. Okay, so A is equal to B. So from here on onwards, it is solving the problem, the third step of mathematical modeling. Okay, so A is equal to B. So equate it. 8 by 40 is equal to 32 by x. So when we cross multiply, we get x is equal to 32 into 40 divided by 8. So 8 ones are 8, 8 fours are 32. Okay, and 4 into 4 is 16. So 160. So x is equal to 160. Therefore total number of parrots are 160. Okay, this is the fourth step of the mathematical modeling. Okay, and that completes this problem. So validating means again once again we should repeat this experiment and we should check. Next time also we'll get number very close to 160. Okay, like this we should validate the model. A similar problem is there in the textbook itself. You can go back some pages and check it out. Exercise 8 2.2, question number 2. Suppose the adjoining figure represent an aerial photograph of a forest with each dot representing a tree. Your purpose is to find the number of trees there are on this tract of land as part of an environmental census. So this is the picture of a forest and there are so many dots in this picture. Okay, and each dot represent a tree. So the total number of dots in this picture will be equal to the total number of trees in that forest. Okay, so that's our understanding. So number of trees is equal to the number of dots in the forest, number of dots in the forest or picture here. So this is also the first stage of mathematical modeling. First stage of mathematical modeling is understanding the problem. So here what we can understand is number of trees is equal to the number of dots in the picture. Now again in the picture, counting all the dots is a tedious task. It takes a lot of time. So instead what we can do is we can count the number of dots in one small area like this. We can take one small area and count the number of dots. So let us say Z is the number of dots in this small area, and if you multiply this Z by the total area of this picture, we get the total number of dots in this picture and hence the total number of trees in the forest. Okay, so the second stage is mathematical description. So if x and y are the length and breadth of this picture, then the area of this picture is x into y is equal to xy units. Okay, and let z be the number of dots in this small area. Okay, let the number of dots in a small unit be z dots. Okay, so here there are z dots. Okay, now if you multiply z into area of this picture, we get total number of trees. So the third point is nothing but the solving the problem. Okay, so here we are solving that problem. Okay, total number of trees is equal to the area of the picture. So area of the picture is x into y. X into y gives area of this picture. So when we multiply area by z, z is the number of dots in this small area. So x into y into z gives the total number of dots in this whole picture, and total number of dots is equal to the total number of trees in the forest. So interpreting the solution, so this xyz is nothing but the total number of dots in the picture, and which that is also equal to the total number of trees in the forest. The last point is validating the model. So again what we can do is we can repeat this experiment once again, and we can choose another unit here, somewhere this here at this portion we can choose, and we can do the repeat the process again, and compare that value with this value xyz. And again what we can do is again we can choose another small area somewhere inside this picture and count the number of dots in that, and we can continue. So every time when we do it, we should get values which are close to xyz, and if it is close to xyz, then this small model is correct. Okay, and that completes this problem. In this problem we'll make an assumption that the dots are uniformly distributed over this area of this picture. Okay, and this assumption comes in first stage of mathematical modeling, that is understanding the problem. In this stage only we'll make that assumption. The unit of measurement of length here should be same. That means if I take breadth in centimeter, length also should be in centimeter. If I take breadth in millimeter, breadth also should be in millimeter, and the small areas size will be 1 unit by 1 unit by 1 unit by 1 unit. Okay, exercise 8 2.2 question number 3. A TV can be purchased for 24,000 rupees cash or for rupees 8,000 cash down payment and 6 monthly installment of rupees 2,800 each. Ali goes to market to buy a TV and he has rupees 8,000 with him. He has now two options. One is to buy TV under installment scheme, or to make cash payment by taking loan from some financial society. The society charges simple interest at the rate of 18% per annum. Simple interest. Which option is better for Ali? Okay, so here to buy TV, this person Ali has two options. One is to go for installment, other is to go for loan. So if you go for installment, cash down payment that he has to pay is rupees 8,000, and after that he has to pay EMI of 2,800 for 6 months. Okay, and if we go for loan from one society there, that society is charging interest rate of 18% per annum. Now which is better, whether installment scheme is better or the loan scheme is better, that's the question. So which will be better means wherever he ends up paying less, that scheme will be better. Okay, so here in installment scheme we don't know the rate of percentage. Okay, here it is given 18% per annum. So here we need to calculate the rate of interest in this installment scheme, and we should compare the rate of interest with the installment scheme to loan scheme. Okay, and whosoever rate of interest is less, that scheme will be better for Ali. Okay, so first what we'll do is we'll calculate the rate of interest for installment scheme. Okay, so in installment scheme we know that the cash price is 24,000, cash down payment is 8,000, therefore the remaining balance that should be paid is 16,000. Okay, but EMI they are charging 2,800 for 6 months. Okay, therefore 6 into 2,800 will be the amount which he is going to pay. Okay, after the down payment. Now the total interest will be equal to total amount paid minus balance. Okay, here balance is 16,000 as it is. So total amount paid, okay, total amount paid only in this 6 months will be equal to 6 into 2,800. So 6 into 2,800 minus 16,000 gives rupees 800. So 800 is the interest which Ali will be paying. After paying a down payment of 8,000, the balance left is 16,000. Therefore in the first month the principal will be 16,000. Okay, and simple interest is given by PTR by 100. Therefore here in the first month I'll take simple interest as SI1, simple interest 1. So this is given by PTR by 100, that is 16,000 into time here it is 1 by 12. Okay, because this interest is just for only 1 month, so into r we don't know, by 100. Similarly for the second month, so he is paying an EMI of 2,800. So 16,000 minus 2,800 is 16,000 minus 2,800. This gives 13,200. So in the second month the simple interest is SI2. So this is, now here principal is 13,200 into 1 by 12 into r we don't know, divided by 100. Now in the third month the principal will be equal to 13,200 minus 2,800. Okay, so this gives 10,400. So in the third month the simple interest will be equal to, here principal is 10,400, so into 1 by 12 into r by 100. So in the fourth month the principal will be, so he pays 2,800, therefore the principal will be the previous balance minus 2,800 gives 7,600. So here simple interest 4 is 7,600 into 1 by 12 into r by 100. So and in the fifth month the principal is 7,600 minus 2,800, it is 4,800. So here the simple interest is equal to 4,800 PTR by 100. So time is 1 by 12. So this is, time is just 1 month, that's why 1 by 12. So into r by 100. So and in the last month the principal will be 4,800 minus 2,800, which is equal to 2,000. Therefore here the simple interest is SI6 is equal to principal into time is 1 by 12 into rate of interest by 100. So it's like this. So for each and every month where he pays EMI, the principal will be different. Okay, now if I sum up the last column, okay, in the last column if I sum up, I'll get simple SI1 plus SI2 plus SI3 plus SI4 plus SI5 plus SI6. If I sum up all the interest in the right hand side, I'll get, so in the right hand side 1 by 2 r, 1 by 2 into r by 100 is common. Okay, so I'm left with 16,000 plus 13,200 plus 10,400 plus 7,600 plus 4,800 plus 2,000. Okay, so this is equal to, now what is the sum of all the interest, S1 plus S2, SI1 plus SI2 plus SI3 plus SI4 plus SI5 plus SI6. So sum of all the interest, it is 800, we just calculated in the previous page. So the total interest paid is 800. So 800 is equal to, now, so 1 by 2 into r by 100. Okay, now 16,000 plus 13,200 plus 10,400 plus 7,600 plus 4,800 plus 2,000 is, I'll get 54,000. Okay, so this is, sorry, 1 by 12 it's 1 by 12 here. Okay, now we can simplify. So 3 4s are 12, 3 1s are 3, 3 8s are 24. So 0 0 0. Okay, then I can cancel these two zeros with these two zeros, and now r is equal to 800 into 4. R is equal to 800 into 4 by 180 if I cross multiply. So this I'll get as 17.77 percentage. Okay, so if Ali goes for installment scheme, then the rate of interest is 17.77 percentage. But if he goes for loan, it is 18 percentage. Okay, loan interest is equal to 18%. Therefore Ali should go for loan. Therefore Ali should take installment scheme. Okay, installment scheme, because the rate of interest in the installment scheme is lesser than the rate of interest of loan scheme. Here in this problem we are taking time as 1 by 12. Okay, always time in this formula SI is equal to PTR by 100. Here time is in years only. Okay, but here we are calculating simple interest for each and every month. Okay, and 1 year has 12 months, that's why we will take time as 1 by 12. Okay, this is for each and every month. And similar problem is there in this textbook itself. If you go back some pages, you will find a similar problem. You can just go through it, and that completes this problem. The next topic is why is mathematical modeling important? There are 3 reasons to gain understanding. So what is mathematical model? It's an mathematical equivalent of real world system. Okay, so by analyzing the mathematical model, we can also understand the real world system, how it works and so on. Okay, and the second point is to predict or forecast or simulate, and the third point is to estimate. All these are given in very simple language, you can read and understand by yourself. So using mathematical model, we can also find the number of trees in a forest. Okay, so there is a problem in the book, and we saw how it works, and we can also find the number of fish in a lake. Okay, so we don't have to catch all the fish in a lake and count them. So there are indirect ways to count how many number of fishes are there in a lake. So this is all done by mathematical model. Okay, and also here you can see exit polls have been used widely to predict the number of seats a party is expected to get in election. So exit polls are the results, election results, which are told before the actual results itself. Okay, after the election and before the results are announced, there will be exit polls, and in that exit polls they will predict which party will win and how many seats they will get. So this is all done using some mathematical model. Exercise A 2.3, question number 1. Based upon the data of the past 5 years, try and forecast the average percentage of marks in mathematics that your school would obtain in class 10 board examination at the end of the year. Okay, now when I'm making this video, the date is February 2023. Okay, now let us say we have data for past 5 years, and in this year what will be the percentage of marks in mathematics we should calculate. Okay, let us say in 2018 the percentage of marks in maths is 76 percentage. Okay, let us say in 2019 the percentage of marks in maths is 80%, and in 2020 the percentage of marks in maths is 85%, and in 2021 the percentage of marks in max is 75%, and in 2022 the percentage of marks in max is 83%. So this year what could be the percentage I should calculate? So I am predicting the future. Okay, now still it is February, exam will be somewhere in March or April. Okay, and result will be somewhere in May. Okay, so how to calculate the pass percentage, sorry, how to calculate the marks obtained? So to do that we need to sum up all this. So when I sum up all this, I'll get 399. Okay, so 76 plus 80 plus 85 plus 75 plus 83, so altogether I'll get 399. Okay, so how many years data I have? Totally 5 years data I have. Okay, therefore in this year the marks obtained, the marks that could be obtained will be percentage of marks will be equal to 399 by 5. So this gives around 79.8. Okay, so this year the percentage of marks that could be obtained will be 79.8%. so this is something which I am predicting that will happen in the future. In this problem I have taken some random data for the percentage of marks scored in max. Okay, but you can check with your school records and get the actual data for the last 5 years, and then you can forecast and see what could be the marks, percentage marks that can be obtained in this current year. Summary of this chapter. In this appendix you have studied the following points. A mathematical model is a mathematical description of a real life situation. Mathematical modeling is the process of creating a mathematical model, solving it and using it to understand the real life problem. The various steps involved in mathematical modeling are understanding the problem, formulating the mathematical model, solving it, interpreting it in the real life situation, and most importantly validating the model. So there are several example problems in this chapter, you have seen it, and also we solved some exercise problems also. The third is develop some mathematical models. So in some exercise problems we developed our own mathematical models, you can check it out. The last one is the importance of mathematical modeling.